So going forward, let's discuss some scenarios or how FortiGate firewall will handle the NAT and how we can configure it in our firewalls. So the idea is same for any vendor, not only FortiGate or even for Palo, it is the same. But the way we configure the NAT varies in FortiGate. I have seen um, some scenarios where maybe the configuration is straightforward in Cisco or Palo, but when it comes to destination NAT translation, it's not a straightforward configuration in FortiGate. We have to configure certain objects and we need to understand the scenario or our requirement, and then we need to configure it accordingly. So I will show you those differences which we have in FortiGate, and we will take it forward from there. So let the firewall start. So just to clear the issue which we faced yesterday, what I did was instead of configuring the port 3 with 35.002, I configured this with 35.003. So since this is being a /30 subnet, dot 3 is the broadcast IP address. So that is the reason why I was not able to communicate to internet from this remote firewall yesterday. So once I cleared this address issue, I was able to communicate to internet, and I was able to validate the license as well. So let's head back to the GUI and let's do the check the configuration from there. The username is admin and the password is test@123 T caps. So by default, the FortiGate firewalls operates in NAT mode. So there is no specific place for us to configure NAT. I mean, there is no separate option to configure NAT. But if the device is operating in central NAT mode, that's a different mode which we have in firewall. In that scenario, we have to configure a separate NAT policies. Now, since we are in the normal mode with mode set to NAT, we configure NAT directly on the policies. So when I say we configure it on policy, whenever we create a policy along with the allow and deny actions, we get the option to configure our NAT. So basically, any traffic that is hitting this policy, it will make use of whatever NAT configuration we configure in this scenario. So by default, the option which is available for NAT, if let's say if I enable NAT, the first option which I have is to use outgoing interface IP address. So let's say if I if I am using my destination interface, the outgoing interface is port 3, or let's say port 3. So whatever IP address I have in this interface, that is 35002, this IP address will be used to make a translation. So any traffic that is leaving from this interface, which is matching this policy, the source IP will be translated to 35002. Now, the translation type which I am talking here is source address translation. We will discuss about the destination translation later, but the configuration which we see here, the configuration which we see in our security policies, it always refers to the source address translation. Okay, so now let's say I'm using my port 3 IP address. Let me configure this real quick. Let's say traffic coming from port 2, which goes to port 3. Okay, so now since I have selected port 3, my source IP address will be 35002. Now, I believe this is very clear for everyone. Now, what if my IP address is fine? I have one IP address on this interface, and if I have thousands of machines in my LAN network, they all are going to use this single IP address. Now, if there are thousands of machines trying to communicate with a single IP address, and if we are not doing a port translation, it will create a problem. Only one IP can be translated to a single destination. If let's say if we have 100 users in our LAN, and if all of them are trying to reach the same destination, let's say 8.8, only one connection will be allowed at a time, because there is no other IP available for us to perform a translation. But if we enable port address translation along with the source translation, IP translation, if port translation is also allowed, then the firewall can also change the source port of the connection. Source port is mostly a random port number, and firewall is allowed to make changes to that source port. Now, the interesting question is, which port range is allowed by the firewall to change? So let's say I'm receiving a connection from my LAN segment, and there can be hundreds of PCs. So we know that the source port of the connection can range anywhere from 1024 to 65,535. That's the normal range for the source port when a PC is initiating the connection. But on the firewall, there is a restriction being set. The firewall is by default, it's allowed to do a port translation only from this range. So this is hardly like around 24,000 ports. That is the default connection allowed for the firewall to perform a port translation. This configuration will be found under the global setting, where the source IP address port range can range from 1024 to 25,000. Now, if I receive a connection more than, let's say if I am receiving like 30,000 connections per a minute on the firewall, and if most of them are going to the same destination, then on the FortiGate firewall, we will end up in a situation where the ports will clash, the sessions will clash. Two connections will request the same port number, and the sessions will clash. In such scenario, you will receive a event log in the firewall saying there is a session clash happening. So if you ever come across this situation, the first option to check is to increase this port range. You can change this to 65,000, there is no issue, but this is the default range. I wanted to keep you informed on this. Now, I will end up in this situation only if I am using one IP for translation. That is my interface IP address. Now, to avoid this situation, what I can do is I can use a dynamic IP pool range. So dynamic IP pool range is nothing but it will let you create an IP pool where you can use a range of address. The external IP range, it can start from 30.1.1. maybe 2, and it can go to 30.1.1. let's say 15. So now you have like 13 IP address available in this range. And if you choose overload, okay, this is the default option. Let's come to overload later. Now I have like 13 IP address in this range. Now all these 13 IP address can be used for translation. Now it depends on the clients. If as long as the client machines comes from the LAN, this range will be used. Now how do we control the port translation? So by default, the method selected for this IP pool is overload. So this is only applicable when we use a dynamic IP pool. The default option is overload. So when we use overload, it will use the same port range, 1024 to 25,000. for this IP ranges. Now you can ask a question like, so if the overload, that is the port translation is available only for dynamic pool, then what will happen if I use the interface IP address? So the default setting, by default, there is only one kind of translation allowed when we use this outgoing interface address. So it will use a IP translation as well as port translation. We cannot control this behavior. This is set by default. Now, there are some corner cases, some scenarios which I want to discuss in detail related to this. So let's go back to our sketchboard. Now let's consider a scenario. Let's discuss a scenario where the firewall policy is configured for source NAT using outgoing interface. So let's consider this for discussion. Allow me some time to sketch the setup. Let's consider this as our server, and let's say it's trying to reach 80.80.80.80. And let's say the IP address on this PC is 10.0.1.10 and 10.0.1.20. And let's say on the WAN interface, I have an IP address 70.70. Now, this is a scenario where the firewall policy or the firewall is going to perform a source NAT using the outgoing interface. So let me show that option once again on the GUI. So we are going to use this scenario where the policy is configured for source NAT, that is via policy, and we are using the outgoing interface address. So as discussed, firewall will be using the outgoing interface IP address, whichever interface IP we have configured on the interface. So in this scenario, it's 70.70. So let's say now this PC1 is trying to, okay, let me see how the policy will look like on the firewall. So basically the firewall will have NAT enabled. And it will say the source IP address range. Any connection coming from 10.0.1.0/24. Let's say the destination is, that is any destination is allowed, and the destination it also in the policy we also need to specify the source and destination interface. So let's say the source interface is A. So source interface is A, and the destination interface is WAN. So destination interface is WAN, and the action is allow. I'm not writing this in detail, but let's say this is what the policy looks like in the firewall. Now, if the PC 10.0.1.10, if it wants to communicate with 8.80.80.80.80, the original packet on the firewall will have the source IP address. I mean, when the firewall receives the packet, the source IP address will be like 10.0.1.10, and the destination IP will be like 80.80.80.80. Now let's say this is a HTTP server which is being hosted. So my connection will be the destination, the protocol or the port number will be 80. Source port, let's say random. And the destination port will be 80, and this connection goes over TCP. Now, since we are using outgoing interface for translation and source NAT is being enabled, the traffic on the source IP on the packet will get translated to 70.70.70.70. That is the interface IP address of the firewall. Now, let's say to differentiate the connection, let's say my source port here is 1025. Now, even though by default firewall will do a port translation when we do SNAT, it is not always mandatory. If there is no other PC requesting connection, or if there is only one session on the firewall that is going through, it don't need to change the source port. It can keep the original port. And the destination IP will be 80.80. Now, as I said, like if there is only one connection, one session going on to the firewall, and it has only one IP to perform the translation, it don't have to change the port. It can still keep the original port number which we received from the client PC. We don't have to change. But let's say now the PC2 also started to communicate with the same server, that is 80.80. So the source IP will look like 10.0.1.20. Destination will be 80.80. Now let's say the source port here is 1026 and the destination port is same 80, the same connection. Now when the firewall tries to perform a NAT for, let me differentiate this. When the firewall tries to perform a NAT for this connection, now firewall will check what IP it has available. It has 70.70 because it's allowed to do the port translation now. It can choose any other IP or any other port number from the range that is allowed. So now firewall can use any random port for the translation. So the connection will look like 70, 70, 70, 70. Going towards, let's say the port can be like 1180, and the destination IP can be 80.80.80.80. Now the difference which I want to highlight here is on GUI we will only get the option to specify what type of NAT we want to use. From GUI, it will only allow us to select the source interface. When we do a NAT translation using the outgoing interface, it will not allow us to decide or control the port. But the behavior is, if there is only one connection requesting, the firewall will not, don't have to change the source port. But only if there are multiple connections coming in, then the firewall will tend to do the source port translation. Now, this is with respect to the source NAT. Now let's go back for the GUI, and now let's discuss the dynamic IP pool. Now let's say if I choose to do a NAT translation, again source NAT translation using the dynamic IP address. So I have 4 options here to choose. That is overload, 1-to-1, fixed port range, and port block allocation. fixed port range and port block allocations are mostly used in carrier grade NATing. That is our mobile networks, the ISPs, Airtel, Geo, they use these kind of NAT translation, and mostly they use it for the connection, because uh, if we consider the normal carrier grade communication, let's say the mobile communication, if I initiate a call from my mobile, there will be around if I remember correctly, there will be like 13 to 16 control connections and another 10 or 15 connections for the data. So they get lot of connections for a single call or message, and to control the translation, they will use fixed port range or port block allocation. So we are not going to discuss this, because this VM firewall is not enabled for those kind of translation. So we will discuss overload and one-to-one. So what is overload? So if I select overload, and since I'm going with the dynamic IP pool, I can configure a range. So overload means we whatever IP address, using a same IP address, we can you can overload the port on it. That is what overload means. So let's, even though if I have a range from 1 to 0.5, I can use the same IP address, but I can overload the port on it. So that is what we mean by overload. And if we choose a one-to-one NATing, this one-to-one NATing it will not allow us to do the port. Here, we are not going to translate the port. Only the IP address is being translated. Now, this one-to-one NATing will be beneficial. This will be very helpful over a VPN, that is over an IPsec channel with overlapping subnets on the remote sites. So if we want to access some server on the remote site, we don't want the IPs to be random. So in such scenario, we will use the one-to-one NAT, where the IPs will remain same for multiple connections. But again, we need to define to which IP address range we have to use. This will be controlled on the policy. So let's have some discussion on this one-to-one. So please give me a minute here. Okay. I'm not able to erase this, so let's see. So we are doing source NAT using IP pool and one-to-one translation. So if we are doing one-to-one translation, and let's say the IP pool is in the range of 70.70.70.71 to 72. Oh, my bad. So let's say this is the IP range which is available from 71 to 70. That is 2 PC. So now in this scenario, let's say PC1 and PC2, they're trying to communicate with our server that is 80.80. Now for the first connection, we will use this 10.0.1.10, and let's say we will bind this to 70. 70.70.71. We have one IP from the pool, and we have already binded it. So we cannot reuse the 71 now because it's been actively used by an existing session. Now let's say the second connection comes in 10.0.1.20, and we have another free IP in the pool. So firewall will use 70.70.70.72. Now let's say there is another PC in the network, which is 10.0.1.30. Now, when this connection comes to the firewall, there is no free IP left in the pool. So firewall won't be able to translate this IP address for this connection. So this connection will fail. So if we are using one-to-one pool, one-to-one NATing, it should be used only in scenarios where it's absolutely necessary. And we know like how many clients are going to connect to a server. That is the mostly used use case where we will use one-to-one NATing. Now, in the same context, if instead of one-to-one, if I am using overload, let's say in the same context, if we use overload, we will be using the IP address from this range, and at the same time we will also change the port number for the connection. So if this request comes in, let's say if this new PC wants to communicate 10.0.1.30 wants to communicate with the server, what the firewall will do is it can use 10.0.1.30. It can bind the same IP address 70.70.70.71. And what it can do is, let's say if the source port of the connection is 1030, maybe it can either use 1030 if this connection is going through 1025. It can use 1030, or it can use any other random port range. 25,460. Any random port range it can use, and it can still use the same IP address from this pool. This is the difference between overload and one-to-one when it comes to source NATing using IP pool. I hope this source translation is clear for everyone here. Now let's discuss the ways to create destination NATing on the firewall. Now destination NATing is something that happens from the outside to inside direction. So the connection will flow from this direction. So configuration of this destination NATing on the firewall is a bit tricky because it's not a straightforward configuration. So before discussing this DNAT, I wanted to introduce you to another object type in the firewall, that is virtual IP. So virtual IP is an address object group which is used in the firewall to control the destination NATing. So the way we define or control the behavior of destination NATing is based on the virtual IP address. So let's give it a name, test. So you can bind this virtual IP group to any interface on the firewall, but most preferably on the interface where you are receiving the traffic. There's a reason for this. Let's say I'm using port 3, that is 35. It has the IP address 35,002, and if I am using an external IP address range, that is 35.0.0.5. Now, this IP address doesn't belong to the subnet which I have on the interface, but still this connection will work because I am binding this IP address to port 3, and I am configuring an external IP address range directly on the interface. So indirectly, even though I'm not assigning this IP address 35005 on the firewall interface, I am indirectly instructing the firewall that 35005 belongs to this firewall. So now if this firewall receives an ARP request on the port 3 for the IP address 35005, the firewall will respond back because firewall believes that 35005 belongs to its own network. Now, if we are doing destination NATing, and if we use an external IP address range which is not in the same range of interface IP address, we need to take proper care to configure the upstream device. The upstream router or firewall, it should know where this network 35005 is present, and the route should be configured accordingly. Only then this setup will work. Now, basically with destination NATing, what we are saying is we are hosting a public IP address on the firewall that is, let's say 35005, and we are translating this to maybe 10.0.0.5. So any connection, let's say if a request comes to the firewall's port 3 interface, and if the destination IP on the packet is 35005, then firewall will translate it to 10.0.0.5. Let me illustrate this to clear the confusion if there is any. So we have discussed source NAT till now. So let's discuss the destination NAT. Let's say we have a firewall configured with DNAT, that is destination NAT. And if the firewall has the interface IP address, let's say 70.70.70.70, now any request can come from internet. And let's say I am hosting an internal server which is running on 10.0.0.1. Now, any user from the ISP internet end, they can try to access the server, but they don't know the private IP address or the internal segments. So any request coming from the server, let's say the server is abc.com. And now if the user resolves this abc.com, and if the IP address resolves to 70.70.70.70, and if the source IP is, let's say, 30.30, now the connection coming from this PC or this internet end will have the source IP address as 30.30, and the destination IP will be 70.70.70. Now, when this packet hits the firewall's interface, let's say when we hit the interface, the firewall is configured to with the translation rule, which says any connection coming on 70.70, translate this to 10.0.0.1. So this is what the firewall is going to do now. It receives a connection on 70.70. It translates this directly to 10.0.0.1 and it will send the connection to the server. Now, since firewall is stateful, it will maintain a session for this. So the reply traffic will use the reverse translation for this, and the connection will be established. This is the basic, the common idea of destination translation. But there are some behaviors with respect to FortiGate, which we will discuss. Okay, and now on the same context, let's discuss one more scenario. Let's say this abc.com is hosted on the port number 80, and I have one more server in the network, let's say, which is, okay, one more service running in the same server, let's say abc.com, same website, which is running on port 443. Now, depending on the connection, firewall can perform a different translation, or let's simplify this. Let's say this is a different server, 10.0.0.2, which is running this 443 connection. Now, in the same context, the firewall rules will change a bit. Now, let's say if the connection coming from this client ABC, if it's trying to reach abc.com on port 80 address, before that, let me define the rule. So in the firewall, we will have a rule which says 70.70. If the connection comes on port 80, then translate this to 10.0.0.1. But if using the same IP address, if the connection comes on 70.70 with port 443, then translate the connection to 10.0.0.2. So basically what we are doing is we are using a single IP address, that is our public IP address, but we are distinguishing the service based on the port. And along with this, we were able to differentiate the server. We are sending the connections to two different internal servers. So you can have one IP address and you can define like all the well-known services, or if you want custom services, you can define the custom services on this. So you can have you can host multiple servers and you can have one public IP address, and using this port translation, you can still make them all accessible to the internet. Now, how the connection will look like for this kind of setup. So if the request comes on 70.70 on port 80, we will translate this to 10.0.0.1 on port 80. But if the same connection comes on 70.70 on port 443, we will translate this to 10.0.0.2 port 443. Now, when I say translation, we are not changing the port on the inside connection. We are only using the port to distinguish which server we want to send the request to. Earlier, in case of source NAT translation, we were changing the ports randomly. Firewall can use this particular setting, and firewall can change the source port of the connection randomly. But in this scenario, we are only changing the destination IP address depending on the port in which we are receiving the connection. We are not randomly changing the source port when we do the translation and send the connection inside. So this is one of the difference we need to keep in mind. So I wanted to illustrate this and configure and show this in the lab, but unfortunately we are running short of time. Today's session was only planned for 1 hour, that is 9 to 10 a.m. So I will use the remaining 8 minutes for any Q&A. So if you have any questions, please feel free to post it on the chat, and I will try to answer to those questions. I know today's session was kind of vague, and maybe for someone it's not easy to grasp. But we will again discuss the same topic in our course in detail, where we will take our own time to discuss. Okay, until the question comes, let me show you one more thing. So we discussed about this VIP object, but we didn't discuss where to use this object. So let's say I am creating a role which says connection coming on port 3. If it comes from 30.0.0.5, translate this to maybe 10.0.0.1. Now we will also get other filters like what kind of source address or service range which we want to do translation, and we also control the port forwarding here, which we will discuss later. But where we will use this VIP object, that's another question. So let's say if I am creating a firewall policy, under NAT, we don't have an option to refer the VIP. So this is only for source translation. So Where we can use the NAT, the VIP object which we created is directly on the destination part. Okay, let me define this first. So let's say the connection is coming from port 3 and the outgoing interface is, let's say server is on port 2. And in the source address range, let's say the connection can, if the connection is coming from internet, it can have any IP address. But the destination, on the other hand, will allow us to configure the uh, virtual IP or server object. Now, if you have observed earlier, it didn't give us the option to choose the server because I have defined this virtual IP object on the port 3. So only if I choose the incoming interface as port 3, firewall will allow me to configure the destination within virtual IP on port 3. Now, services can be any, or you can define it. So this is how we will control the destination NAT. Now with this rule, what we have said is if a connection comes on the port 3 for the IP address 30005, translate this to 10001 directly. Now on the same connection, on the same rule, if I say if the external port, if the connection comes for TCP and if the connection comes for port 80, you can either use it to translate to port 80. You can use the same port or you can translate the same connection to 443 or 8080, depending on the scenario. So if we use this kind of connection, now what will happen is for whatever connection that comes in on port 3, with IP address 30005 on TCP port 80, firewall will perform a destination NAT translation and it will change the destination IP to 10001 and it will change the port number to 8080. So there are additional things which I wanted to discuss with respect to DNAT, but unfortunately we are running short on time. So we will close the session here. So any questions, please feel free to drop it in the chat. I will try to answer to my best. So Dinesh, you have raised your question, so I have unmuted you. Please ask your question here.
Yeah, sure. Actually, chat is disabled. That's the reason I can't able to chat.
Mhm,
Okay. In this net, actually in this policy, we have configured the outgoing interface,
mhm,
and in VIP also we are configuring the interface.
mhm,
So, if any traffic coming from internet from outside to DMH zone anything,
mhm.
so whether I need to mention the what the scenario, what the consideration I will need to take for defining the outgoing interface in policy as well as in
Okay, so this policy, which we have defined it for outside to inside connection.
yes.
So we are selecting on which interface we will receive the uh, traffic. Guys, I have enabled the chat. I'm sorry that it was disabled earlier. I have enabled the chat now. So this policy is one moment. Yeah. So this policy is defined for a connection coming from outside to inside because we have discussed the destination NAT scenario here. So in this, we are defining the interface in which the connection is going to hit the firewall. That is our port 3, which is, let's assume it is our WAN interface. So whatever connection comes in on port 35.002 will be, sorry, on port 3 will be translated. But for which IP address we are going to do the translation, that is being defined in the virtual IP object which we created. So again, in the virtual IP object, we have defined on which interface we are receiving this connection, that is port 3. Now there are scenarios where we won't select this port 3, the interface, when we create the virtual IP object. That's a different use case. We won't change this, we won't select this interface, or we will keep it to any. That is also possible, but it depends on the scenario. But for the scenario which we discussed, we are translating connection which we received on port 3 and translating from 3505 to 10.1. I hope that answered the question. Okay, now I'm getting the questions in chat. So Pavan has requested, can you explain difference between flow-based and proxy-based in inspection mode? So Pavan, we will discuss this flow-based and policy-based difference when we discuss the firewall policy. So in this, we haven't discussed the firewall policy as a whole. So there is another session planned for firewall policy to show how the policy lookup will happen, how the policy will be matched, and how the session will be created. So during those time, we will discuss flow and proxy based. So username switch has a question. Can you explain source NAT overload once again? So source NAT overload, we will get this when we use the dynamic IP pool. So when we create an IP pool for the source NAT translation, this is where we get the overload option. So overload is nothing, but we are using a same IP address. Let's say I am defining 70.0.1 and the range is 70.0.1. Now with this configuration, there is only one IP address available in the range. But if I have multiple connections to do a NAT translation, this is where the overload will be helpful. So using this one IP address, just by changing the port, I'm allowing all the connections. So that is the main difference in overload. So I can either use a single IP address here, or I can use a range. So Adi has a question, what is ZTNA? So ZTNA is Zero Trust Network Access, where if you use FortiClient in your laptop, and if let's say you have a scenario where your PCs in your organization is not provided by the IT and users are bringing in their own PC, then you can install ZTNA, the FortiClient. So FortiClient will run certain checks on the PC. It will check certain directories on the PC, and it will also scan your PC for any malware. So based on the scan result, the FortiClient will assign different tags for you. So that is what we call Zero Trust Network Access, and we call it as ZTNet tags. So based on the tag, you can configure the firewall policy. So only if you have certain tags with you, your connection will be allowed. If you don't have the tag, you won't be allowed. So let me simplify this. If let's say if you have a vulnerable software version installed in your laptop, FortiClient will scan your PC and it will say your PC is vulnerable because you haven't installed the patch. So for that reason, it will assign a vulnerability tag to you. And in the policy, there'll be a rule written which says if any user coming with vulnerability tag, please don't allow the connection. So firewall will not allow you to access resources. So Rajesh has asked the question, would it be possible to cover VDOM in the upcoming session? Rajesh, VDOM is planned for one of the session. I have planned it for the day one, but because of time restriction, we have skipped that topic. Let me see if I can excuse it in some other day. So Dhaval has asked the question, how to enable ZTNA in firewall. So for ZTNA, you can directly create objects here. So it's by default enabled, but there are some supporting components needed, like you need an EMS server, you need a PC with FortiClient installed to make use of ZTNA. But the configuration is already, you have the option already available in the firewall. So Harihara Sudan has a question. Sir, VLAN configure for SNAT and DNAT. So the VLAN is possible with respect to source NAT and DNAT, but the only thing is, in policy earlier we defined the interfaces based on the physical interfaces. But if I have a VLAN created, let's say on the firewall, I should have covered this VLAN creation yesterday, but we were running sort of time. So let's say now I have this VLAN with a VLAN ID 100 created on my port 2 interface. Let's say this is 0.1/24. Now I have a VLAN interface on the firewall, which is binded to my port 2. Now, if I had to create a policy on the firewall, now I have the option to select the VLAN interface directly. So this is my VLAN interface. So just by creating the VLAN interface, now I can use the same object which we created. Okay, we created the object with interface. Now I can define my NAT translation rules here. So let's say port 3. So now any connection that is coming from this VLAN 100, and if it's going towards port 3, we will use the source NAT translation using the outgoing interface IP address. The same way we can create interface and we can play around. Dinesh asked the question, could you please explain central source NAT and central DNAT? So Dinesh, at the moment, this firewall is not configured for central NAT mode. So once I configure central NAT mode, I'll be able to discuss and provide you a demo for that. Central NAT is something I have planned for the upcoming course. So because that will take some time. So Momi has a question. If we are going to outside from LAN to WAN and access the internet, hence doing source NAT, do we need to set up DNAT as well? So Momin, firewall is a stateful device. So it will maintain a session. You don't have to create a source NAT role. You have to create a source NAT role for your inbound to outbound connection, but you don't have to create another rule for outbound to inbound. So if, let's say, if we consider this scenario, so if I consider the same setup for source NAT, I can write a rule in the firewall which says any connection coming from 10.0.0.1, translate this to 70.70.70.70 and send the connection to internet. Now this entry will be available in the firewall. Now let's say this is a TCP connection. So the TCP connection will by default be kept for 3,600 seconds, not 60. 3,600 seconds on the firewall. So for this time period, this session will stay active on the firewall if it's an established session. There are certain differences if it's a half open or half closed connections. But if it's an established session, the connection will be kept in the firewall session table for 3,600 seconds. Now within this time period, now if a response comes back on the firewall will use the same session to perform a DNAT. So in this scenario, you don't need a separate DNAT rule to allow the connection inside. As long as the session is active, the connection will be allowed. So Prakash has a question, what is the difference between standard versus zero trust? So in standard connection, with respect to standard, you are not classifying the machines. In firewall, we have an option. Let me show you that will give a better sense. So in the firewall, you can create these objects, address objects, where you can define a PC with respect to MAC range. So you can select this device MAC address and you can define a PC. Let's say this is a HR PC, and you can enter whatever MAC range you have, and you can refer this object in your security policy. But you will be only able to do this only if you have some physical control on the PC. That is like you provided the PC to your HRs. You know what MAC address they are. But in terms of ZTNA, you are not in this scenario, in the normal standard scenario, you are establishing a physical trust on the firewall by configuring their MAC address and defining who is using that and from which interface the connection is going to come in. But if the users are bringing their own devices and you can't blindly trust their PCs. So let's say you are an enterprise administrator and you are letting your users to bring in their own PCs. And if there is no antivirus software or if there is no malware detection programs installed in those PCs, and if their PCs are infected, if a hacker has access to those PCs, they can easily compromise your network. Nowadays, most of the companies with this remote work from home, they are allowing people to install VPN applications on their own PCs and connect to corporate network. In such scenario, you don't know like where the threat is going to come in. So if you have zero trust configured, if you're not trusting any of your PCs, any of the PCs in your network, and if you're allowing the FortiClient application to scan for malwares and antivirus and then assign tags based on that, you can have some control in policy, like what connections you're allowing and what connections you're denying. So Bharat has a question. In SourceNet, if both the PCs have mapped to same IP address, will they differentiate by port number? Bharat, what you are asking is, if I understand correctly, you are asking that two PCs coming in with the same IP address, uh, 10.0.0.1. This is what you're asking, and if they are trying to access two different destination port, that is 80 and 443. The problem is if they are in the same switch segment, the PC will not allow you to configure these PCs in same IP address, because when you configure an IP address, there will be a check being done to see if there is any duplicate IP present in the network. So you won't be allowed to make this configuration. But on the firewall, if you are using a VDOM and if these connections comes on two different VDOM, then this is possible. But VDOM is something which we haven't explained in this class, so we will discuss this later. So Mani has a question regarding the NAT. Is it possible to translate the same port, for example, 80 to 80? So Mani, that is possible. So let me show you that. So in virtual IP, you can define the same port here. So if the connection comes on 35005 and if we are sending it to 10001, we can still use the same port. If I disable the port forwarding, again, whatever source port the connection comes in, the same port will be used. But if I want to customize that port connection, I can use it here. I can do this for TCP, UDP, SCTP, and ICMP as well. In ICMP, there is no port, but there is one too many. So there can be some applications running in your network which kind of sends a keep alive. And if you have a load balancer and if you're kind of having multiple servers behind, then you can use ICMP many to many or one to one for those keep alive connections. But again, it depends on the scenario. So Ravi has a question: how to modify the default port range from 1024 to 25,000? Ravi is asking about this, and change it to 24 to 65,534. So Ravi, this is possible. It's simple. So set, okay, the connection has closed. So you can simply run the command. Let me close this. So this particular configuration is available under config system global. So show full time grep port. So if I define set IP source port range, it will allow me to configure the range. By default, it's 1024 to 25,000, but I can change it to, let's say, 25,000 to 26,000. Let's say 1024 to 26,000. 24 is a well-known port. It's throwing some error, but it is possible we can change this option here. So Ganesh Ram has a question. Is ETNA like network access control? It is kind of similar, but there are some additional features available when you use ZTNA. So Ram, could you cover upcoming channel configuration in the upcoming classes? So do we have plan for it? Yeah. Ram, I have the plan for IPsec configuration on the last day, that is day 6. I will hopefully cover it there. So Lakshmi Narayanan has a question. In source NAT, we are translating local server IP to firewall WAN IP to reach 8.8, while the return traffic source IP will be 8.8. Destination is firewall WAN IP, and the same will be translated to local server IP. The same is happening in DNAT as well. What's the difference? Can you please clarify? Okay, so what forgot your name. So what Lakshmi Narayanan is asking here is, let me go back to this. If we do a source NAT, our connection is translated from 10.0.0.1 to 70.70. But when the return traffic comes in, in the return connection, the source IP will be in the return connection, the source will be 70.70 and the destination will be 10.0.0.1. How this is different from the destination NAT which we configure. So Lakshmi Narayan, the difference is where we are initiating the connection. Now, firewall is allowing this return traffic only because firewall has a session table maintained for this. That only because of that, the return traffic for this is allowed. Now, let's say if I am initiating a new connection, let's say there is a DNAT rule configured on the firewall, and if I initiate a new connection on 70.70 for port 80, and if there is no DNAT rule, configured on the firewall, firewall don't know where to send this connection. And now since the connection is coming on 70.70, that is the interface IP address for port 80, let's say the HTTP service is disabled on this interface, firewall will simply drop this connection. So only if we define a DNAT rule, connections originated from the outside will be allowed in. With the source NAT rule, what we are doing is we are originating the connections from inside to outside. But with the DNAT rule, we are allowing the connections to be initiated from outside to inside. So this is what I refer as direction when we were discussing NAT initially. So based on the direction, we will decide whether it's a source NAT or destination NAT. I hope I answered your question, Lakshmi Narayanan. So Pavan Kalyan has a question. Firewall have types of modes and in difference. So Pavan, we discussed this yesterday. So with respect to modes, we have standard NAT mode, then transparent mode, and virtual wire mode. We have discussed this yesterday. I will direct you to check the recording, please. Roshan has a question. Can you send recording for reference like yesterday? Sure, Roshan, we will send the recording with you later. So team, we are running short of time. So let's close the session here today. So We will see you next Saturday and for some other interesting topics with respect to FortiGate. I really want to thank you all for your time, that too on a Sunday morning. I really appreciate it, and have a good day.